question 2B, paper 2 of the 2018 DEB mocks. I did the first bit, but I'll just very quickly go over it with you again. Basically, you had to show that x was 7.5. So what you need to realise is that if you draw a line down here from the centre of this, you will cut this angle in half. Now, the reason you cut it in half, I did explain in class, is because the line between, mightn't look very obvious, but the line from the centre to the tangent, point of tangency, is a right angle. And we can show that these two triangles are congruent by RHS. They have the same H and they have the same one other side, and they are both right angles, which means that individually then, both of these angles are half of 1.29, which is 0.645. So 0.645, this is x because x is a radius of this circle, okay? And again, from here to here is 20. This is just an arc that's being swept out, so 20, 20, and anywhere along this line is 20 from here because it's a radius of the larger circle. So if that's x, this is 20 minus x. So let me draw that triangle outside. So you have x, you have 20 minus x, and you have the angle 0.645 radians. Okay? So from that, you can see that the sine of 0.645 radians is equal to x opposite over hypotenuse over 20 minus x. From that, 20 minus x multiplied by the sine of 0.645 is equal to x, multiply out, 20 sine 0.645, 20 times the sine is 0.645, minus x times the sine of 0.645 is equal to x, just multiplying that out. Then 20 sine 0.645, get your x's on one side, is equal to x plus x sine 0.645. Factor out the x, so x times 1 plus sine 0.645 is equal to 20 sine 0.645. So then x is just 20 sine, I hope you can see that, 0.645 over 1 plus sine 0.645. And that should turn out to be approximately 7.5. So hopefully you can see that. That's how you get x. Okay, I'm going to rub that out now. And we'll just put x in now as being 7.5 from now on. Okay, so x is 7.5. So now the next part of the question was to find this area, the area of the shaded region that was inside the sector but not inside the circle. You should attempt this whether or not you could do the first bit, okay? All you have to say to get any marks at all is the area that they want, the area of the bit that they want, which if you like you can draw as shaded. So you can say the area of the shaded bit. So the bit they're looking for is this shaded bit here. The area of the shaded bit is equal to the area of the sector, the large sector, hopefully you can see that, minus the area of the circle. Okay? Now, that should be very straightforward. The large sector has a radius length of 20, you can see it here, and it has an angle in here of 1.2 radians. The circle has a radius of 7.5. So the area of a sector of a circle is the area of a full circle, pi r squared, times whatever fraction the angle is of either 360 or 2 pi, depending on whether it's radians or degrees. So in this case, it's radians. So whatever fraction 1.2 radians is out of 2 pi radians, because there are 2 pi radians in a full circle, that's the fraction that the area of this sector is going to be of the full area of a circle. Okay, and that minus the area of a circle is pi r squared. And r in this case is 7.5. Pi r squared, or in this case is 20 squared. Okay, and I think when you put that in, you get, obviously your pi's are out, r squared theta in radians over 2. So you should get, let me see, 258. The whole thing should work out to be 81.285. Okay, I'm not going to start doing the calculations because I'm trying to get as much done as possible. Okay, if you have any problem with that, let's get back to me. But that should work out to be 81.285. That was easy pickings because they told you about the 7.5. So it wasn't as if you had to get the 7.5 in the first part. You had to show it, but at least you knew it was 7.5. So you should, everybody should have been able to do that question, irrespective of whether they got the first part right or not. Okay, the next part of the question was asking you to find the perimeter of this piece here. And again, I would say read everything twice to make sure you're answering the question that's being asked. So the perimeter would be this shape here, which is y, y, and I'll call that w. Okay, so there's your shape, w and y and y. Okay, now if you look, y, if I draw out that triangle again that we looked at earlier, there's our right angle, there's our y, and this piece here was our piece going down. Now, that's this full length here right now. So remember, this was 7.5, the whole thing is 20, this is 20, this is 20, so 20 take away 7.5 gives us that length there, so that length there is 12.5. 20 take away 7.5 gives you the 12.5. Okay, this is 7.5. So from this we can work out y. Obviously y is also on this side here. Okay, y is here and here. So y is the square root of 12.5 squared minus 7.5 squared. And y turns out to be 10. Okay, so these guys are easy, 10 and 10. We now need to find this here. Now this is an arc length of this circle. So here's the circle and here's the arc length. So here's the circle, there's the arc, the sector of the circle, that's 7.5, it's x, but it's 7.5, 7.5, and we want this length here. So remember, the length of an arc of a circle is whatever fraction the angle is out of 2 pi, in the case of it being radians, times the full length around a full circle, which is 2 pi r. So the length L here is r theta, where theta is in radians. So we know r is 7.5, so really all we need to find that length there is what the theta is. Okay, so how do we find that theta? Here's the theta in here that we want to find. Okay, now again, because we have two triangles here that are congruent, we can say as long as we find this angle here, we can double it and that will give us the theta. Okay, that's the triangle there, that's it there. So to find this angle, we can use the fact that we know that the tan of this angle, remember here's a right angle triangle, here's the hypotenuse, so this is the opposite, this is the adjacent for this angle here. So we can say the tan of alpha is equal to 10 divided by 7.5. The tan of alpha is the opposite divided by the adjacent. Okay, calculator. So alpha is the tan inverse of 10 over 7.5, remembering that it is in radians, okay? Actually, we don't even need that because I forgot we have these angles here as well. So we don't even need to use that. We know that that angle there, I forgot I'd taken it out. We know that this angle here was half of the full angle. The full one was 1.29. So this is 0.645. So actually, to find alpha, alpha is just, we know that alpha plus 0.645 radians, now remember, is equal to 90 degrees, but that in radians is pi over 2. Remember, 2 pi radians is 360 degrees, pi radians is 180, and pi over 2 radians is 90 degrees. So alpha plus 0.645 radians is pi over 2 radians. So alpha is equal to pi over 2 minus 0.645. Okay, and that turns out to be actually, I don't think they bothered leaving, they just left it like that. Okay, so that's alpha. Now, we need to double that because that's only one side here, so we need to double that. So our theta will be twice alpha, which is multiply that by 2. So 2 times pi over 2 is pi minus 1.29. That's if we multiply this by 2. So that's our theta. So now the length, the full perimeter of this here is 7.5. We write, hang on a second, 7.5. No, apologies. Where did I draw the 7.5? Oh yeah. We want this bit. So we know that this is 20, or 10 rather. This is 10. This is 10, because we've worked it out here. Taking the wrong diagram. And this is our L. Okay? Our L, remember we said, is R times theta. So it's 7.5 times theta. Okay, and we know what theta is. This is theta here. So the total perimeter of that shape is 10 plus 7.5 times pi minus 1.29. And that turns out to be 10 plus 10 plus pi multiplied, or sorry, to be pi minus 1.29 multiplied by 7.5. $33.887. $33.887. And I think they said to the nearest centimetres, so 34 centimetres. Okay, hopefully that makes sense. Any questions, just send me an email.